It's Monday morning, which means it's time for your weekly dose of optimism about the world of software development. Don't worry, I still don't believe AI will replace developers anytime soon, but there is no denying the job is quickly changing. I'm sure you have heard this being said 1,000 times by now, but today we should actually unpack it. A few days ago I was doing some code review sessions, and I realized that all of a sudden my colleagues are much more diligent with their comments. In my experience, comments are usually used in two specific scenarios. On one hand, you are commenting your code as a last attempt to actually understand the solution you proposed. On the other hand, and this was especially common in the Java world, auto-generated setters and getters often came with equally redundant comments. Of course, most developers would remove them, but these days redundant comments are pumping up your lines of code numbers, and, as we all know, that's the only relevant metric in the code generation era. These days, however, the comments we see in pull requests are often surprisingly descriptive, even though they may still be somewhat redundant. And usually these comments are a strong sign that the code was generated by an LLM. In my experience, if you use AI to generate code, you will probably use AI to debug it as well. And if that's the case, those comments are actually useful because they give the LLM more context. And this brings me back to the idea that our job has already changed significantly. However, you need appropriate skills for these new software roles, and in this Monday morning review, we'll discuss some of the most important ones. The most important skill a developer can have in 2026 is ownership. Trust me, this is actually way harder than it sounds. Sure, you can generate all your code now, but keep in mind that you are still the main person responsible for that work. And I'm talking from experience here. An AI agent can generate a feature, refactor a module, and update the documentation in a fraction of the time, all while appearing to be very professional. But it does not actually own the product, and it does not know which compromise will become painful 6 months from now. And I witnessed this firsthand in large codebases with both Codex and Claude. And no, it wasn't a skill issue. This means the most valuable engineer is no longer necessarily the person who can produce code the fastest. That competition is kind of over, and we, the humans, lost in a spectacular fashion. The valuable engineer is the person who understands the domain well enough to direct that machine. They know what should be built, what should be ignored, where complexity is justified, and where the agent is confidently creating a maintenance problem. The second important skill is judgment, or what people increasingly like to call taste. Taste sounds vague, especially in engineering, where we prefer things that can be measured, benchmarked, and placed inside an obscure Confluence page. But taste is simply the ability to distinguish between something that works and something that is worth shipping. Coding agents are exceptionally good at producing plausible solutions. They can add helper functions, compatibility layers, factories, adapters, and 12 new files to solve a problem that actually required changing only one conditional. And without judgment, this feels productive. But producing more software is not necessarily progress. Sometimes, the best contribution is deleting the feature request, using the platform capability that already exists, or deciding that the edge case affects 3 people and does not justify turning the codebase into a distributed system. And there is a deeply technical reason why coding agents default to this kind of complexity. LLMs operate on local context windows, so they optimize heavily for the immediate prompt and the specific file they are looking at. As a result, they are brilliant at microarchitecture, but they lack a proper management of the full picture. An agent doesn't know and doesn't care that the helper function it just generated actually duplicates a core library dependency introduced 3 years ago that sits in a different module. However, if you want to play devil's advocate, some argue that duplicating code and bad practices don't really matter anymore. This also changes how we think about seniority. A senior developer used to be partly defined by the amount of implementation experience they had accumulated. That still matters, because experience is usually where judgment and taste come from. But the practical output of that experience is changing. You may spend less time implementing the solution yourself and more time evaluating 5 solutions produced in 10 minutes. You need to recognize which one fits the architecture, which one creates unnecessary coupling, and which one only appears correct because the agent wrote a very persuasive explanation next to it. The only problem here is that existing senior devs have this acquired experience through years of actually writing code, and, honestly, I'm not sure how new developers are supposed to acquire this judgment if they outsource the entire learning process to an agent from day one. Another relevant skill in this new world is context management, and this one is especially important because I believe it'll end up changing our codebases quite a lot in the future. And this is where those comments I mentioned earlier become interesting. A comment that explains what the code is doing is often redundant. The code should already tell us that. A comment that explains why the obvious solution is wrong, which business rule is being protected, or what constraint must not be violated is valuable context. It helps the next developer, and it also helps the next agent session. And this is the perfect time to have an honest discussion, because I need to address the elephant in the room. I have always been somewhat skeptical about AI, but over the past 6 months, it has become increasingly difficult to ignore how quickly software development is changing. So, while I'm accepting that things will change, I do believe skills are more relevant than ever, and what's more important, developers are not going anywhere. I recently read this article which outlines the current situation pretty well. The clearest way to understand how our job is changing is to stop thinking about software development as the act of writing code. But before going into more details about this, please let me tell you a few words about today's sponsor. Code reviews haven't changed that much in the last 20 years. You get a bunch of files in alphabetical order and must scroll through lines for hours. But with the amount of AI-generated code hitting production these days, they are now more important than ever. And, let's be honest, the process is pretty tedious. That's why big PRs sit for days, with reviewers basically either blindly accepting anything that's longer than a few hundred lines, or providing nitpick comments with sparse architectural feedback. This is where CodeRabbit Review comes into play. This is a new review interface that takes a pull request and reorganizes it from a flat file list into ordered cohorts and layers, so you can read the change in the order it was actually built. And, with features like code peek, you can click any variable, function, class or type name in the diff, and you'll get its likely definition and usages in line, so you can follow the code without leaving the page. On top of that, the chat agent allows you to make inquiries right where you are working. It has the full context of the pull request with every cohort, layer and changed line, and it gives you all the answers in the same view you're already working in. Please check out the link in the description to find out more about CodeRabbit. Back to the video, writing code is only the middle part of the job. Before that, someone has to decide what should be built. After that, someone has to verify that the result is correct, integrate it into a real system, deploy it, monitor it, maintain it, and eventually explain why it broke at 2 in the morning. Granted, that middle part was where all the fun was at, and sadly, it is probably going away in professional settings because AI is compressing it quite aggressively. But the work surrounding implementation is proving much harder to remove. You can think about software development as 3 connected layers: deciding, executing, and delivering. The deciding layer includes understanding the problem, talking to users, interpreting vague requirements, identifying constraints, and occasionally discovering that the feature everyone has been discussing for 3 weeks should not actually exist. The execution layer includes designing and implementing the solution. This is the area where coding agents are improving the fastest, but keep in mind that none of the frontier models are 100% accurate here. The delivery layer includes testing, reviewing, integrating, securing, deploying, monitoring, maintaining, and accepting responsibility when reality disagrees with the demo. AI can generate an impressive amount of code inside the execution layer, but companies do not make money by accumulating generated code, they make money by delivering working products that solve useful problems without exposing everyone's private data or deleting the production database. And this is also why vibe coding should not be confused with professional software engineering. Vibe coding is perfectly reasonable for prototypes, disposable tools, experiments, and personal projects. You describe the result, the model generates something, and you keep prompting until the application appears to work. Or, if you are to believe the Anthropic Fable 5 demos, you can one-shot pretty much anything. The problem starts when this workflow is presented as a replacement for engineering. Professional development requires someone to understand the system, review the changes, evaluate the risks, and remain accountable for the result. And here is the personal part of this video. I have to be honest, there are times when I have a hard time making sense of this whole situation. I was recently discussing with one of my colleagues who helps with some of the amazing video editing you are seeing on this channel, and I was complaining about the low number of new subscribers reaching the channel. He pointed out that one of the reasons for our apparent lack of real success on YouTube is that we don't clearly pick a side. While we are kind of AI skeptic, we still believe the technology is pretty useful. So, most of the time, our takes are kind of inconvenient. AI is neither completely useless, nor the magical replacement for developers that some people desperately want it to be. And unfortunately, nuance is not particularly good for YouTube. And as much as I'd love to ride the hype with titles like "Software development is dead" or "The AI bubble is bursting," the truth is, I have no idea what the future will bring for us. What I'm certain of is that in an era where some old man wants to commoditize intelligence and know-how, critical thinking and skills will be more valuable than ever. And before wrapping things up, here is your awesome trivia story of the day. It has absolutely nothing to do with software engineering, but it has everything to do with what happens when you mistake a plausible design for actual execution. Back in the early 1970s, an elite structural engineer named William Le Mesurier designed the Citigroup Center in New York City. Because of St. Peter's Lutheran Church on the site, he had to put the entire 59-story skyscraper on top of 4 massive stilts, positioned not at the corners, but in the middle of the building's edges. At that time, the building was considered a masterpiece of execution. But a few years after it was built, an undergraduate engineering student was doing her thesis and started calculating the wind loads on the building when she noticed something terrifying. Le Mesurier's team had calculated wind hitting the building dead-on, which was standard practice. But they hadn't properly accounted for winds hitting the building at a 45-degree angle right on the corners. Then, when Le Mesurier went back to check his initial plans, he discovered a catastrophic compromise. During construction, the specified welded joints had been swapped for cheaper bolted joints because it was faster and seemed good enough for the load. On paper, this looked like a standard optimization. In reality, however, those bolted joints changed the structural integrity entirely. Under a strong quartering wind, the joints could fail and the skyscraper could literally topple over into the middle of Manhattan. What makes this story important is the ownership angle. Le Mesurier didn't blame the contractor and he didn't hide behind his perfect blueprints. He went to the executives, worked with city officials on an emergency evacuation plan in case a major storm hit, and hired welding crews to secretly work through the night for weeks, reinforcing every single joint while the city slept. They rushed the repairs during hurricane season, while Hurricane Ella briefly threatened the East Coast before fortunately turning away from New York. If you liked this video, you should consider joining our community where I'm posting more dedicated weekly content. Please don't forget to like, subscribe, and until next time, thank you for watching.